This kind of exemplar-based reasoning is consistent with reasoning seen in other areas as well. For example, in Chapter 10 on problem solving, we discuss several papers that emphasize the role that instance and analogical transfer play in solving problems. The laser and tumor problem is solved much more quickly by participants who had read the description of the general and fortress problem. With respect to medical expertise, the suggestion is that experts have accumulated extensive clinical knowledge, and they rely on that clinical knowledge to make their diagnoses, rather than rule knowledge or prototypical knowledge. The research discussed earlier by Devantier et al. Is consistent with this idea as well. Knowledge encapsulation. The suggestion that medical experts rely on exemplar retrieval and extensive clinical experience to generate diagnostic hypotheses rather than rules and prototypes highlights a potential problem in the way in which physicians are trained. Typically, medical training emphasizes basic biomedical facts, biochemistry, anatomy, etc. Medical training does not generally emphasize exemplar retrieval. It does not generally emphasize problem solving by analogy. And as the research by Devantier points out, it is not until the later stages of medical residency that physicians begin to acquire the requisite exemplar knowledge. So how do medical experts incorporate their initial medical school training in basic science with their clinical experience? One possibility is knowledge encapsulation, which refers to the integration of basic biomedical concepts with clinical propositions into a single representation. 1992. In other words, as physicians gain experience, they integrate the basic knowledge that was acquired during medical school with features and facts about each clinical case they encounter. Because clinical features are the most frequently encountered features and serve as the entry into this knowledge representation, the biomedical propositions are subsumed or encapsulated. In other words, medical experts think and classify at the level of remembered instances and exemplars, but do not lose access to the basic biomedical facts. In some ways, this is like the kind of reasoning shown by the landscape architects in the tree classification study. As discussed earlier, they tended to group trees together on the basis of how they interacted with them, rather than on the basis of their taxonomic relatedness, but they did not lose access to that knowledge, and were able to switch to taxonomic relationships when engaging in a categorical induction task. With encapsulated knowledge, the suggestion is that the preferred level of identification and reasoning is goal-relevant and clinically relevant. As such, experienced physicians tend to heavily weight the degree to which a current patient reminds them of previous patients, but this does not mean that they have lost access to basic biomedical features. ch11 and Schmitz wrote an excellent paper on encapsulated knowledge in medicine and have noted that as expertise increases, physicians tend to make diagnoses and produce diagnostic explanations at high levels of generality. 1992. Interestingly, as expertise in medicine increases, doctors' responses reflect highly abstract knowledge rather than the emphasis on specific subordinate levels, as is seen in bird identification and fish identification. This does not mean medical experts are operating at a superordinate level, but it does mean the biological aspects enter in only at the highest levels. The suggestion from ch11 and Schmitz is that medical diagnosis is a result of encapsulated knowledge, possibly related to individual exemplar comparisons, as described by Brooks et al. The knowledge encapsulation hypothesis also explains a curious phenomenon observed in medicine. Medical experts are often prone to what is known as the intermediate effect. The intermediate effect is found when performance does not increase monotonically with expertise. Figure 11.7 shows an example of the intermediate effect. The dashed line shows a hypothetical performance acquisition process in which increasing experience leads to correspondingly better performance, but the intermediate effect, solid line, shows a decrease in performance relative to what should be expected. Although this is not seen in every aspect of performance, it suggests that the knowledge base of novices is fairly sparse and dominated by biomedical fact. The knowledge base of experts is rich and dominated by clinical experience. The degradation seen at the intermediate level reflects the inadequacy of the basic biomedical knowledge combined with minimal clinical experience. Ch11 and others have suggested that this may be the point at which knowledge encapsulation occurs. Intermediates have started to move away from a reliance on basic science, but have not encapsulated the basic science with clinical experience. These intermediates may be very good at making a diagnosis, but may not be able to integrate knowledge between the two domains. Figure 11.7, a hypothetical example showing the intermediate effect in medical expertise. The actual performance acquisition is not monotonic. Okay, so it's like a scatter plot, except it's categories instead. So on the x-axis on the left you have novice, then you have intermediate about a third of the way over, and expert on the far right, and on the y-axis you have performance. So when you look at the line of expected, it's like a linear increase from novice to expert, and the performance increases like with an upward slope. When you look at the observed effect, the intermediate effect, novices do okay, then they do worse as intermediates, then they do way better as experts. So this dip in the intermediate stage can be shown by when they have to swap from rules to experience, and they encapsulate the rules in their experience, called knowledge encapsulation. Interestingly, Devantier et al. Found that the intermediate effect disappeared when the participants were asked to make forced choice judgments on patient management cases, but the intermediate effect persisted when the forced choice items reflected more complex knowledge. It is possible that for these intermediates, management information has been encapsulated, but endocrinological knowledge has not yet encapsulated with clinical experience. The impact of research on medical education. As discussed, medical experts are characterized by their reliance on exemplar memory, as well as their knowledge of diagnostic prototypes and diagnostic rules. Over the course of several years, students must acquire the rudimentary scientific knowledge and incorporate this basic knowledge with clinical expertise in order to become effective processors of medicine. Some have suggested that medical experts rely on encapsulated knowledge in order to make decisions and arrive at conclusions quickly. This may reflect a reliance on System 1 rather than System 2 thinking, and indeed, the degree to which diagnostic errors are made may reflect a reliance on System 1. This tendency has resulted in some tension within the medical expertise and medical training field. Some researchers, such as Pat Cross-Carey, are champions of an approach known as the default interventionist approach. 2003, the default interventionist approach assumes that System 1 is the fast default approach to most cognition. Physicians who rely on exemplar retrieval and instance memory are relying on System 1, and as a result might commit errors if they arrive at a diagnosis too quickly. Cross-Carey suggests training physicians to intervene by slowing down to monitor performance and to allow System 2 to produce a more deliberative response. This does not mean that exemplar information should be discarded, but rather that the deliberative practitioner takes the time to look for possible cognitive errors. On the other hand, researchers like Jeff Norman emphasize the importance of instance memory and exemplar retrieval and suggest that slowing down and attempting to intervene with System 2 might undermine the effects of acquired expertise. In many ways, Norman's approach is fairly consistent with other aspects of the expertise literature and shares many similarities with the role of memory in chess performance and the reliance of deep feature categories in physics expertise. When I was writing this text, both of these approaches were receiving considerable attention. Summary. This chapter attempts to answer the questions of what an expert is, how expertise develops, and what kind of cognitive advantages are most closely associated with expertise. It should be clear that there is no single answer to any of these questions. Expertise can be defined as a function of the time spent in deliberate practice. This has given rise to the so-called 10,000-hour rule, and this seems to characterize many kinds of skilled performers. For other kinds of expertise, however, the 10,000-hour rule does not seem to hold. At the very least, it may be a necessary component of expertise in some skills, but is by no means a sufficient predictor of expertise. Expertise changes in the way people perform. Experts rely on schemas and consolidated memories. In medical expertise and in other complex domains, physicians seem to rely on encapsulated knowledge. When playing chess, experts seem to rely on chunks of knowledge related to games they have played or studied. With respect to skilled professions, experts seem to rely on groupings that emphasize very specific goals related to how they interact with the objects of their expertise. Across many domains, it seems clear that experts rely on rich associations between concepts and across different levels of a conceptual hierarchy. Experts in bird identification can simultaneously access basic, subordinate, and superordinate level information. Experts in tree identification can work flexibly with goal-oriented categories and taxonomic categories. Experts in medical diagnosis can arrive at a diagnosis via specific item similarity without losing access to deep biomedical knowledge. It is this activation of different levels in a semantic network in parallel that seems to be one of the true hallmarks of cognitive expertise. Note: in the US and Canada, the term attending physician refers to a doctor who has completed medical school, residency, and now works at a hospital or clinic, admitting and seeing patients and supervising medical residents. It's a region-specific term for a physician with extensive experience and training.